I'd like to introduce our presenter today, Tom Lamb. Tom's got over 15 years of experience in industrial safety, and he is the senior safety product specialist with Omron. And I'm going to turn it over to Tom from here. And Tom, take it away, sir.
Thank you, Pepper. Good morning, everyone, and welcome to Safety Fundamentals and Tools, where for the next few minutes, we will review. We're going to go about an inch deep and about 50 feet wide on a lot of topics related to machine safeguarding. So if anyone has any questions during the presentation, please type them into the chat box, and we'll be happy to expand or on any of the topics. So we will jump right into it. Oh. There we go. All right, so just real quickly, who is Omron? We are a multinational, over $9 billion now dollar company, including global safety services, which that is the Omron business unit, the sub business unit that I am in within our industrial automation sector. We also have a healthcare sector. You've probably seen the Omron blood pressure cuffs, very large part of that market. We also get into automotive subcomponents, social systems related to the transportation system. And also we have an industrial automation board level. So we also manufacture components down to the board level. Okay, so our agenda for today, we just touched on a little bit about, or we're going to touch on a little bit of our safety expertise and the deep bench of support that you have available to you for the asking. We're going to move on then to risk assessments. What are they? What do they mean? Why are they important? What are the ramifications? And then we'll finish up with just a brief select safety products review. And these are the tools that you have available to implement to address the risk that has been identified in your machine and or process. So we're up to 43 and growing TUV functional safety certified engineers. That is a training class that we do offer. It's a 9-week course. We do also have a TUV technician level training class that is a 3-day course, a little bit less intensive. We do have one TUV functional safety certified expert. There are only 33 of these in the world. We do participate in over 60 of the Americas-based global standard safety committees, including ANSI, ISO, RIA, etc. We have over 30 years experience designing and implementing machine safeguarding solutions. Okay, so who needs help when you're tasked with guarding a machine? Anyone that's tasked with understanding and implementing machine safeguarding efforts. That's who we aim to help. And I like to jump around a little bit on these slides, so forgive me if I don't follow along exactly. Omron pays me 100% of the time to keep up to date with safety standards and how to apply them using safety devices. And I can tell you, many times it bores me to absolute tears. So I really feel for anybody that is tasked with machine safety, and they also have maybe 15 or 20 other jobs, coordinating with production and maintenance and everything that's involved in actually getting products out the door. So the main point of that is machine safeguarding with the hundreds, if not thousands of shalls and shall nots that are in all of the regulations. They're typically not a core competency for most people. It's just, it's not realistic time-wise to ask that of someone. 52% of manufacturers report uncertainty. Am I applying the proper standard in the proper place for the proper reason? 78% of manufacturers report just the lack of resources available and skill necessary to deploy a safe and compliant safety system. And this is a big one. 93%. We've done over 10,000 risk assessments now globally, and 93% of the equipment that we assess, they're not compliant. And it's not due, most of the time, it's not due to a lack of due diligence, lack of interest, lack of funding. It's just there are so many shalls and shall nots that something can slip by, and it usually does. So this brings to the next section. The number one question that I get when I'm out on the manufacturing floor and we're looking at a machine is, where exactly does it say that I have to guard machines and I have to do any of this stuff that we're talking about? Then I would refer you to the left side of the screen. This is OSHA's General Duty Clause, and it's General Duty Clause 5A1. Each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards that are causing or likely to cause death or serious physical harm to his employees. And note the wording "shall furnish." It's not when it's, they did this very specifically. It's not, we highly recommend that you guard your equipment, or what a great idea it would be if you guard your equipment. Each employer shall furnish. So there is not a question about whether the machines need to be guarded or not, which leads to the number two question that I get asked is, that machine over there, that 400-ton press that we've been using since the 40s, is that one grandfathered in? You know, we haven't made any modifications on it in the 25 years that we've had it. So we're good there, right? The answer is no. If that machine is used in production, then it must be guarded. So no matter the age of your equipment, we got to guard it. And so, yeah, ignorance of the law is not excuse. So just not knowing, with OSHA being the enforcement arm of the government. Matter of fact, this morning I was looking up the most recent figure for violation. OSHA can fine up to $13,653 per day. And they give you an abatement date or a remediation date to fix whatever they have identified. And if it's not done by that point, then it's up to $13,653 per day per machine from that point forward. So it can get quite expensive. And doing it right the first time with respect to machine safeguarding. And this goes back to the earlier point. It's not due to lack of interest, lack of funding. It's just not a core competency. And so a series of patchwork guarding ends up on a machine. Push button is added here. A small in-feed conveyor is made over there. So, it's part of a continuous improvement program where 1 year a modification is made, a year and a half or 2 years may pass, and another small modification. Drawings, the control schematics do not get updated, machines do not get reassessed, and it can unintentionally create a very dangerous and sometimes fatal situation. So what we end up with is a machine with the appearance of safety. Maybe light curtains are deployed, they're mounted properly, the minimum safe distance calculation has been run, but then that light curtain is wired back to a standard PLC, which would negate the entire safety circuit of that machine. So that would be the appearance of safety. So a non-compliant safety solution, it's a waste of both time and money. So our motto is, hey, let's get in, let's do it right, let's do it once, and then we don't have to budget in additional time and resources into guarding this machine because we know it has been assessed, we know it's been remediated, and we are good to go. Okay, next up, this is OSHA's Big Three. When they're writing citations, OSHA being the enforcement arm, the top three that are most often cited. First one, OSHA 1910-147, lockout tagout. OSHA 1910-212, which is the general requirements for all machines. This is the area that I specifically live in 98% of the time. And the subsection of that, the point of operation of machines whose operation exposes an employee to injury shall be guarded. And note that same language, shall be guarded, not just highly recommended. And the guarding device shall be in conformity with any appropriate standard. That means you want a independent third-party certified safety device. We want a device that is designed to fail to a safe state and prevent the operator from having any part of their body in a danger zone during the operating cycle. And then the third, OSHA 1910-219, mechanical power transmission. Anything below 7 feet from the working floor shall be guarded. And that typically, and these are easy to spot, right? Different OSHA inspectors have different backgrounds. Some come from measuring effluent or noise pollution. Machine safeguarding might not be a core competency of that particular OSHA inspector. So these are easy to identify at a glance. Flywheels, shafts, pulleys, gears. If something's turning or shearing, and it's below 7 feet, it's easy to point out and write a citation. So that would lead us into section 1, risk assessment, risk reduction. And again, this is like a 10,000-foot view of the risk assessment process that Omron follows. There are many different software packages. There are many different ways to approach a risk assessment. The big point of note on this is pick whichever risk assessment system makes the most sense for you and be consistent with that throughout your facility or facilities. Okay, so what is risk? The possibility that something bad or unpleasant will happen. That's from Merriam-Webster. Two main factors: severity. How bad is that injury? And the probability, how likely is that to happen? And this is a function of how long is the person exposed to that hazard and how often is a person exposed to that hazard. So how often does that hazardous event occur? The technical and human possibilities of avoiding or limiting the harm. That is the speed of the hazard versus reaction time of people. And OSHA does have a constant for a person falling forward, 63 inches per second. That's the constant that OSHA has come up with. Okay, so what is the risk assessment process? The goal of the risk assessment is to reduce the risk to a tolerable or acceptable level. And the risk assessment process shall continue until acceptable risk is achieved. So you can probably see the word or the two words in that sentence that might cause the most confusion: tolerable risk, acceptable risk. This is something that the person that is looking at the machine must decide for in their particular situation. What is tolerable to one person might not be tolerable to another. So coming up with a general consensus of what tolerable means will set you up for success in conducting your your risk assessment. So ANSI B11.0 is harmonized with standard ISO 12100, and I'll have just a little bit more on that on the next 2 slides forward. But both of them define risk assessment. That's the process by which the intended use of the machine, the tasks, and the hazards and the level of risk are determined. The risk assessment process is that entire process of identifying the hazards, assessing that risk, reducing that risk, and documenting those results. The risk reduction is the part of the risk assessment process that involves eliminating or the elimination of hazards or selection of other appropriate and feasible risk reduction measures that reduce the probability of harm or its severity. So why do a risk assessment? We create a safer working environment to employees. It helps ensure the proper safeguarding. This goes back to the do it once, do it right the first time. There is a cost benefit to safeguarding on the front end. And I have a slide on that in just a moment. And finally, to comply with national and international standards. It costs money not to guard your equipment. So what is that cost? From the Center for Disease Control, we're looking at upwards of $1 million in direct cost, $2 million in indirect costs. Indirect costs for, say, a company that's not self-insured, their annual insurance premiums go up whenever there's a recordable incident or an accident. Cost of an amputation. You're pushing $65,000, $70,000 in direct costs with that, and $141,000 plus in indirect costs. You're looking at retraining, rewriting of procedures, implementing guards on those areas where that recordable or that accident occurred. The National Safety Council estimates that for every dollar that's invested, the return on investment is $2 to $6. Our own insurance company estimates that closer to $9 in savings. In 2017, there were 220 fatalities in the United States from unguarded machines. There were over 1,500 amputations in the USA from unguarded machines. So what is the process per ANSI? B11.0 and ISO 12100. ANSI B11.0, it specifies the basic terminology, principles, and methodology for achieving acceptable risk in machinery design and use. ISO 12100 was one of the principal resource documents used in developing ANSI B11.0. Complying with ISO 12100 will not assure compliance with the requirements of ANSI B11.0, but conversely, compliance with ANSI B11.0 will automatically result in compliance with the requirements of ISO 12100. So this is where we begin at step one, prepare for and set limits of the assessment. This is the gather your team, talk with the operator, the person that is most intimately involved with that machine or process on a day-to-day and minute-by-minute basis. They're often the most overlooked resource for identifying hazards. We talked about tolerable risk. Get that consensus on what that means. What is the goal? What are we willing to tolerate? Step two, identify, and Omron, we use the ANSI model. We identify the task, the specific task, and the specific hazard that's associated with that task. So there may be dozens of tasks involved in a process of, say, a stamping press. The operator is entering and exiting that hazardous area multiple times per shift. Then we assess that initial risk. We use a scoring system. The best way to be able to prioritize say you have 25 machines, 50 machines, 100 machines, is to assign a numerical value to that machine, and that will allow you to prioritize. Then we assess, then we actually reduce risk. We implement those safeguarding measures. Then we look at it after the safeguarding measures have been proposed, and what is the residual risk? Is it tolerable? So then we ultimately say, is that acceptable or not? If it's not, you go back, you start over. If it is, fantastic. Let's validate it, let's document it, and then let's move on. Example of a risk scoring system. It's everything from a slight injury requiring first aid, which is best practices in the industry, is a Band-Aid. Anything more than a Band-Aid would be in the serious injury category. So as we're looking at each task, we say, all right, what's the worst that can happen as far as injury? What's the worst that can happen if that happens and we need first aid? And we work our way down the flow chart, and it puts us into a risk reduction category. So from that category, we say, okay, we have an X number score on this machine. Okay, it is indeed hazardous, and it's kind of a spoiler alert, but most equipment does have a potential, especially in industrial manufacturing machines. The risk ends up pretty high. So we do want a control reliable safety circuit. That means redundant and monitored. So this chart explains that relationship between the risk score and the minimum safety circuit requirement for that hazard. So how do we do that? Okay, so we look at the hierarchy of controls. So as we work our way through the hierarchy of controls, we first focus on the top two layers. When we're performing corrective action, they are most effective at solving these risk reduction challenges than the bottom three rows. The number one being, if we can work with the machine builder and eliminate or engineer that hazard out of the machine to begin with, that is best case scenario. We design it out. The second row, safeguarding technologies and protective devices. This is where we work for the vast majority of the space. We already have the machines. They may be old. We need to put hard guarding. We need to use interlocks. We need to use those third-party safety devices on that machine in an appropriate manner. Those are the engineering controls. As we go down this slide, we get to the less effective protective measures, warning lights, signs, training and procedures, PPE. Now, all of these have the same thing in common. That is, we're relying on a human to make a decision not to do something that's going to result in an injury. So these are administrative controls, and we want to avoid leaving that decision to a person, if at all possible. Okay, so that leads us to Omron Safety Product Portfolio. And this is just a cross section of some of the tools that are available to help in these safeguarding efforts. We look at our safety system as an input, logic, and output. So choosing the proper safety interlock, safety rated laser scanner, light curtain, going back this newest generation, we're getting into safety PLCs, where you can now have safety on the same communication bus system on your same PLC as you're using for everything else. Pretty powerful stuff. So some of the different types of safety interlocks, mechanical, like the tongue and key, probably the type that most people are aware of. These are excellent for what they are. We have very compact, we have made of different materials depending on the environment. As a large door may sag over time, maybe you've got a 6-foot square door going into an area. As that door sags, that key can bang into that interlock, and they can take a lot of pounding, but eventually it's going to be destroyed. So that would lead us to non-contact safety interlocks. So these are safety rated interlocks that are designed to just come within close proximity of each other and are much more forgiving than the mechanical style. Then we get into guard locking safety interlocks. These actually have solenoid locking, like power to lock or power to unlock. You apply 24 volts to the switch, and you can lock and unlock that safety interlock. So you can hold a door closed until it is safe to enter. So many different body styles and shapes to accomplish that task. We even have a safety relay that can measure the back EMF of a motor. You know, say that there's a motor spinning down, somebody hits a request to enter or an e-stop in a caged in work area. But maybe it's connected to a huge saw blade that has to spin down. Maybe it takes a minute. Well, as long as that motor's turning, that motor is creating a back EMF or electromotive force. The relay will monitor that, and it will not unlock the door until it is safe to enter. So there's some pretty creative ways to balance the safeguarding versus production. And just an example, I put this up here at Omron now. We have a safety component selection guide with dozens of different types of machinery and examples of the type of technologies that are used in safeguarding those machines. Some requirements for interlock switches. Any guard that is movable or removable. If you have a sliding guard or a hinged guard, interlock that guard for whatever. For a few bucks, you can put an appropriate safety device on that movable guard and make it safe and compliant. There are also safety limit switches. These need to be used very carefully, as depending on how they're mounted, it is very easy to bypass a safety mechanical limit switch. And one thing of note, safety rated mechanical limit switches have the exact same mounting footprint as their non-safe counterpart. So an easy way to tell at a glance if you're using a safety rated device, look for a circle with an arrow pointing to the right, somewhere printed somewhere on the label or etched on that device. And that will tell you that that is indeed the safety version of that safety limit switch. So don't use proximity switches, don't use standard limit switches as safety devices. So light curtain, two different types of protection. The point of operation, that's where we're getting right up close to that hazard. We need to be able to guard. We need to be able to detect and know if a finger or a hand has come into that hazardous area. And then we also have perimeter type, which is we just want to know if approach to this machine has occurred, if someone is getting within a larger area. Which leads to the brand new F3SG SR light curtain, and our marketing department ensures me that it is the most advanced safety light curtain on the market today. Just a few of the features that this light curtain has: tri-colored area beam indicators. They are green, amber, and red. So they'll indicate, hey, we're fine, everything's clear. Amber, if the lens starts getting dirty and there's about to start having false triggering due to the environment, maybe it's dusty, powder, whatever it is, the lights will go amber. So they'll tell you, hey, come wipe me down before I false trigger. And then red would indicate a lockout state. And you can change the meaning of those area beam indicators if you want, to indicate muting, to indicate many, many different situations. We've increased the temperature operating range from -30 degrees C now up to 55 degrees C. So if you're in the food and beverage or food and commodity, in the freezer areas, the food preparation We now have there's now a viable solution to this technology in those areas. It'll auto detect NPN or PNP. So no longer do you have to select the right one and hope it gets installed properly. IO Link, if you're collecting data, I've worked with many companies that are doing constant improvement or Six Sigma projects. So you can get, I believe it's almost 60 different IO Link variables that you can get back feedback from these light curtains. Best in class muting, you can program it via Bluetooth. That's just a couple of different wiring examples. We do have safety mats and edges. You may have seen them like on the old timey elevators. I don't know if any still exist, but they use the bumpers, or I'm sorry, the safety edges as the doors close to make sure they don't close on a person. Safety laser scanner. This is 4 inches high, 5 inches wide, 4 meter. It'll scan out to 4 meters with a safety zone. And there are 2 additional warning zones that go out to 15 meters. And there are 70 of these zones that can be programmed for your different applications. And you'll notice there are also, we love the area beam indicators across the front of the laser scanner. So you can, at a glance, you can look at the laser scanner and tell where the intrusion into that safety zone has occurred without having to connect a PC or go back and plug into the device itself. It is a 270-degree scanning angle. Because it is a safety device, it must see a part present for 2 scans minimum, and it must see a scan for 2 beams minimum. That's part of the optical standard. And it will detect down to the absolute minimum allowed reflectivity, 1.8%. So the flattest of flat black, it will detect it at the 4 and 15 meter ranges. Safety controllers and relays. Everything from a simple safety monitoring relay for just a handful of safety points, maybe an e-stop, a light curtain. If you wanted to add a little bit of logic, wired logic, and or type functionality, series of relays to do that. The real sweet spot is our G9 SP. It is a programmable safety relay. You can add in, it's a function block program. You drag over a picture of a light curtain, you drag over a picture of a safety mat. So if you need to add any type of logic, you just drag that function in, drag one wire to the other, and you're done. Then we go all the way up into integrated safety, where we're getting into using DeviceNet, safety over EtherCAT, and SIP safety. This is just a great summary of why to use the G9 SP. All of our safety monitoring relays can be replaced with the G9 SP. There is a promotional kit that we have that includes everything that you'll need, which brings us to the NXSL series. This is the latest and greatest. This is unique to Omron in the industrial safety world. We have 2 different networks on a single safety system that is fail-safe over EtherCAT and SIP safety on the same controller. Superior diagnostics, easy maintenance, fast troubleshooting without the need for a PC. And then developing your safety system within this environment. We have software called Sysmax Studio. It will auto-program. It will auto-detect your safety devices out on the line and auto-program your function blocks. It makes it quick. We just did a project, and the engineer at this customer told us that he saved 25 to 30% of his commissioning time using this technology. And this is just a very busy splash screen of what is possible and unique with Omron, and that is using integrated safety with a hybrid or as a hybrid system. You connect your SIP safety robots, you connect your e-stops, your interlocks, your light curtains. You're doing your motion control, safety over Ethercat, all going back to the same controller that just goes back to a simple switch that from there can go to a PC. You can send information to the cloud for gathering data. And again, a lot of Six Sigma initiatives. They love their data. So the more they can get, the better. And a splash screen of just a cross section of some of the devices that we do have available. And I do want to mention, because I think I've got about a minute and a half, maybe a minute left. We do have a wide variety of emergency stops and rope pulls, which is, just another version of an emergency stop. Personally, I do not consider e-stops or rope pulls as safety devices because the vast majority of the time, if someone is going and they're intentionally pushing one of these devices, something bad has already happened. And we're just removing power from whatever horrible situation has just occurred. So while e-stops very often, they are integral part of safety system, I do not think of them as preventing, or not very often do they actually prevent an accident from occurring. So I think I hit it right up. Yep, right about plus or minus 30 seconds.
Yeah, that's pretty awesome, Tom, as far as the timing goes. I had one question. Somebody direct messaged me and said, what was the most recent industrial accident that you saw? I guess they wanted some details on maybe what machine or what happened to the operator or whatever.
Absolutely. There's a steel slitting company in Middle Tennessee that down in the scrap bin, periodically somebody would have to crawl down into the scrap bin and sweep it out down to another level. And a push button, a gate and a push button, like a request to enter button, had been added. That request to access and the gate had happened years ago. No drawings were updated. Personnel had changed, so that tribal knowledge had gone away. And then another modification to that system had happened that was going to eliminate the need for a person to go down into that scrap bin because it was hazardous. Think like the trash compactor sequence in Star Wars, right? Pretty brutal. And through a series of mousetrap-like events, a photo eye was blocked, the push button had been pushed, and the gate had closed behind the person going down into the bin, and that person was crushed into that scrap compactor. So it was a pretty brutal, but completely avoidable situation.
There's another question on the chat window, if you can see that over on your side. By the way, what's that koozie you have there? I noticed.
Oh, what a great question. That innovative IDM there. Keeping my Sprite Zero cold. Let's see, Tom, does the responsibility for performing risk assessments on the machine lie with the OEM, end user, or a combination of both? Excellent question. Third most asked question. The performing the risk assessment in the United States falls solely onto the end user. And this is where, especially with new machines, a lot of confusion occurs. The end user perception is that the OEM or the system integrator, they have designed this machine. It is safe. It has a warranty. We're not going to make any modifications. That OEM they're the ones who need to come in and enhance our safety. But in the US, that is not the case, because the same machine that an OEM ships to an end user, that machine might be guarded significantly different that if it's in the corner of a manufacturing space up against two walls, or if it's smack dab in the middle with 4 or more travel aisles around it, just due to the traffic patterns and the adjacent hazards. So it does fall to the end user. I've seen some larger corporations start to add into their RFQ and into their equipment sourcing that an engineering review and validation must be due or must accompany that machine, so that there's a starting point and some accountability from the OEM side. But in the absence of a contractual obligation, it falls to the end user.
I had another direct message, and certainly if anybody needs to bail out, we appreciate you coming. There is a couple more questions. There's one that just came in right there, Tom.
Okay. If a risk assessment is performed and the machine is brought up to specification, can the machine claim to be ISO or ANSI certified? This more regards to a machine being designed rather than already existing. Is there a benefit to being able to claim code certification? That's a great question. If ISO compliant doesn't necessarily mean ANSI, but ANSI does mean ISO. So there is a benefit depending, and this is where if you have an OEM that is manufacturing a machine, say in Europe, where they have their rules are completely flip-flopped. The OEM owns the risk assessment, and there's an entire industry built around following those machines as those machines are bought and sold and need to be reassessed. Like because you can't knowingly sell or you're not supposed to knowingly sell an unsafe machine. So if you make machine, a palletizer, say, that has safeguarding, and then you make a B version of that same palletizer, but all the safeguarding is stripped off of it, then you're opening yourself up to legal actions from an OEM perspective. If that answers the question.
Yeah, thank you, Christopher. There was one other question that came in, Tom. Does OSHA require a risk assessment?
What an excellent question. No, OSHA does not require a risk assessment, just that the equipment be guarded. ANSI and ISO will illuminate or illustrate those steps and tell you how to do one.
Okay, and then there was one more direct message to me. Do you have to have control reliability on every machine?
Another good question. The answer is no, because it all depends on the risk assessment. You can have single channel with monitoring if that assessed risk dictates that level of safety circuit is addressing that level of risk that is present.
All right, cool. So it looks like I don't see anything more in the chat box. Tom, we thank you so much for taking time today to come and talk to everybody on this call, and appreciate you sharing your knowledge with us. I've recorded this, and so it'll be available later. I'll be able to email this out to anybody on this call. And hopefully you guys, if there's anybody of your teammates that would benefit from parts or all of this, please forward it to them. Tom, thank you again.